Okay, so in this one, this side is 10. This is x. See, they're calling it x right there. This is 15. And they're saying, find the area of the trapezoid, ANQS, ANQS. This is a trapezoid right here. They want us to find the shaded area of the trapezoid, So how do we find the area? And they say, hint, your expression will involve the variable x. So we're going to have some kind of algebraic expression here, some kind of x expression. So how do we find the area of a trapezoid? Well, if you look down to the formulas from the exam 3 notes, which are really these guys, which I got off the exam 2 notes, the area of a trapezoid formula is right here. Trapezoid area, right there. So it's the one of the bases plus the other base, right, added together, times the height. And the height, notice, has to be 90 degrees to the 2 bases. Remember, we've talked about that a lot. In any shape, height is 90 degrees to base, right? If you want to measure your height, you have to go straight down to the ground. So that'll be important. All divided by 2. All right, so let's go back and use that formula. So the area of the trapezoid is going to be one of the bases plus the other base times the height divided by 2. So what are the 2 bases and what's the height? Well, it's a little tricky. We're going to have to use this is one of the bases, this is the other base, and this is the height right here. So this is the base right here. Okay, that's not so well done. So there's base, and then of course here's the big bases over there. So okay, so now why is that? Why that way? Well, because that height, notice, is perpendicular, right angle, 90 degrees to both of the bases. So the trapezoid is sitting on its side. In other words, the height is actually going sideways, like we've laid down the trapezoid. So the height goes at 90 degrees to the 2 bases. Okay, so the area of the trapezoid is going to be the big B, that's 10. That's right from here to here. That's easy. That's just 10. They gave us that. So that's 10 plus. Now, what's the little b? Well, the little b is going to be 10 minus x. Do you see how I'm coming up with that? Because x is from here to here. That's x, right? And all the way top and bottom is 10. Just getting that right there. I just moved it over. Right? 10 is all the way top and bottom. X is here, so then this top part is 10 minus x, isn't it? It's the whole thing, take away the bottom part. So this little b equals 10 minus x. So the big B is 10, the little b is 10 minus x. Times the height, and the height is 15, isn't it? Just get it from down here. All over 2. So that makes sense how I did that? The big B is 10, the little b is 10, subtract x. It's the whole thing, subtract the bottom part. 10 minus x, that's the little b, 10 minus x. The big B is 10 times 15, the height is 15, right there, all over 2. You can simplify that a little bit, maybe just one step. 10 and 10, that's 20, minus x, times 15, all over 2. That's it. That's as far as we can go on that one. Let me put a box around that. That's our answer. Type that in, just like that, with that x, that whole x expression. That's what they were saying. It will involve the variable x. So that whole expression, you can't simplify it anymore than that. So type in that whole expression for the area of a trapezoid. And now the second part, they want us to find the perimeter of the trapezoid. So how do we find perimeter? So let me draw a line of separation here and write, we're going to do perimeter of the trap. So to find the perimeter of the trapezoid, well, that's all four edges added, right? Remember, perimeter means all the way around the object. So let's just do the four edges. Here we go. I'll do the first edge right here. I'm going to start right down here, and I'm just going to go all the way around. So that's 10. And then the top part, which is 15. And then this part right here, which we already know is 10 minus x. 10, 15, 10 minus x. And now the last part is the trickiest part. We want to find this part right here, right? That's the last of the four edges of the trapezoid. Well, how do you find that? Well, you know what we're going to do. Look at that. It's part of a right triangle, isn't it? This is like A, B, which is actually X, and C. It's A squared plus B squared is C squared. Right? Whenever we have a right triangle, we've done this several times, right? Whenever you have a right triangle, A squared plus B squared is C squared. The A is 15. 15. Plus the B, that's just X. And the C is what we're trying to find. So what do we do to solve for C there? Oh, 15 squared, use your calculator. 15 squared is 225. You use your calculator, 15 squared is 225. And then last step, square rooted, huh? Cancels. And so C will equal, whoops, try that again. C will equal 225 plus x squared. So that is what goes right over here. It's going to be the square root of 225
So
plus
wouldn't it be the original equation that you had? So when you square root it, could we just assume that it would be 15 plus x equals c?
Oh yeah, good, really
225?
good question, Martine. Super good question. It's actually not, but people think that. Yeah, because you think, can't we just square root that and just square root that, and it just goes back to 15 and x? Not true. Let me prove it. That's really important that you know that's not true. Great question. Thanks for asking that. Let me prove it to you. What if you had square root of 4 plus 9? Now we know that's square root of 13, and your calculator will tell us, I'll get that real quick. That's 3.6, 3.60, blah, 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 blah. Right? What if you square rooted that, you would just get 2. If you square rooted 9, you'd get 3. We would think it's 5, but it's not 5, is it? So do you understand? Does everybody understand? Martine's question is a great one. So it's really important. You cannot square root the items when you have adding, subtracting. That's the moral of the story. Martine's question is a great one. He's saying, why can't we just square root these guys? Just square root that and square root that and get 15 and x. It's not true. You cannot square root the items when you're added and subtracted. This proves it. Look at this right here. Square root of 4 plus 9, that should be 2 plus 3, right? Square root of 4 is just 2. Square root of 9 is 3. That should be 5, but it's not. Square root of 13 is no way 5. So it proves that's just not right. Yeah, but it sure looks right, doesn't it? It just looks right. So you got to watch out. It'll fool you because it looks so good, but it's just not right. You have to just leave it. You actually can't. It's because of the plus. When you have, or minus, when you have adding or subtracting, you actually cannot square root the items. They must stay separate, must just stay like that. Great question. Really good question. And then we can do one more step of simplification here. We can do like 10, 15, and 10. That'd be what? 20, 30, 35? 35 minus x plus the square root of 225 plus x squared. And that's it. That is our answer. I'll put a box around it. That's as good as it gets. That's what we put there in that box. Does that make sense how we found the perimeter of that trapezoid? I just had to do all 4 edges, and 3 of them were easy, 10, 15, and this one we already had 10 minus x. The C was the 4th edge. And we had to do a whole bunch of work to find C. We had to set up a right triangle, a squared plus b squared, so 15 squared plus x squared, which is 225 plus x squared, and then square root it to turn c squared into regular c. And then you have to leave the square root on it. You can't square root those items. When you have adding or subtracting, you can't do it. And then I simplify, add the numbers up. 35 minus x plus the square root of 225 plus x squared. That's what we type into the box. So that's pretty tricky. There we go.